Hello, everyone. I wanted to share with you guys some information on how to find certain pieces of information if given a circle. So what's really common when we're learning about circles is sometimes they want us to take a chunk out of that circle, and maybe they want us to find the entire area of this chunk, which we call a sector. So sometimes they want us to find area of the sector. Or another thing that's very common is they might want us to find the arc length of that sector. So what I have highlighted there is just the distance, or this could be considered measured in degrees. We can talk more about that. But let's say we just want to find the length. We'll say arc length. In some type of units. Let's just say we want to find inches today. Okay, so we'd have area of a sector. If we're using inches, that would be in inches squared. Okay, so how do we find these two things? Well, we absolutely need either the diameter or the radius. And if we're given the diameter, we could just divide the diameter into 2, and we would get our radius, which let's say our radius is 14.5. So the measure from the center to the outside is my radius, 14.5. Well, today I really wanted to focus on this basic relationship that I'm just calling piece over whole. And I found that with 90% of my students, they like really succeed in finding these two different either area of a sector or arc length when they understand the relationship of piece over whole. So I'm going to step away from that picture for just a moment here. We can come back to it. I want us to think about this in 3 main categories. One, we're going to have degrees, or this could be in radians. Basically, that's just going to be the measurement of my angle, right? So that's my angle measurement, degrees or radians. I'm also going to have area as part of this relationship. And then I'm going to also have circumference. And basically, in my piece over whole relationship, I could relate all 3 of these different categories together. So let's say I want to set up an equation here. And for my degrees and radians, I'm going to have the measure of whatever piece I'm trying to find over my entire degrees or radians of my circle. So when I'm saying piece over whole, I'm talking about the piece of the circle divided by that whole item of the circle, which we'll get into specifics in just a second here. And let's say I want to set this equal to my area, which is also going to be a piece over whole. We're stripping this equation down to something very simple, so it's really easy to memorize without any complicated formulas. All we have to think in our heads is piece over whole. So all 3 categories are just the same for now. We're going to start plugging in different information here in just a moment. So let's go up, and I told you guys we're going to need information about the radius, but we're also going to need information about, let's say, the degrees. Okay, they could give us radians, but let's stick with degrees for this example. And let's say the measurement of this central angle is 28 degrees. Well, this would be our first piece that we can actually plug into our equation here. So let's say instead of piece over whole for degrees, I can actually plug in some numbers, right? My piece is going to be the 28 degrees. What do I plug in for whole? Well, this is just a fact I'm going to have to remember. This entire circle, for any single problem, the whole circle degrees equals 360. Okay, if it's radians, we can still use piece over whole, but we're just going to set the whole equal to 2 pi instead of 360 degrees. So just in case you're expected to use radians for your problem, just use 2 pi. We're going to use 360 degrees. So I already have one entire fraction set up. Now, in our problem, we had to find both the area of the sector and also the arc length in inches. And I'm going to color code this a little better for you because I'm noticing here that maybe my colors are a little confusing. So my degrees are going to be the purple column. My area is going to be green. And my circumference will put in red. So arc length is really just a piece of the circumference. So we'll get to that in a bit. What's my piece over whole for area? I need to actually find that area piece, right? We don't know what this area is. If I were to fill in this whole piece, we have no clue. We don't know. So we can call that X for now. And that's totally fine to leave one of the values as unknown. That's really the whole point, is we want to find something here. What do we do for the whole? Well, for the whole, I look at my category. My category is area. So it wouldn't make sense to plug in 360 degrees again, because that was in a whole nother category of my actual angle measurement. This time I want to find the whole area. The whole area we know is pi r squared. So I go to my r value. I notice that my radius is equal to 14.5. So this is going to become pi times 14.5 squared. And I can simplify this. If I do 14.5 squared, I'm going to get 210.25 times pi is just equal to 660.52. So there's my whole value for my area. It's 660 and change. Let's go to our final category. What information, piece over whole, can we plug in? Well, that piece from our circumference, that was what we were trying to find for our arc length. So a lot of times in geometry, you'll notice S is used for arc length. So let's just say I want to find whatever that arc length value is. Well, what's going to be my whole circumference? My whole circumference is going to be equal to 2 pi r. So that's just equal to my whole circumference. So I want to plug in 2 times pi times 14.5 to get my radius. And when I calculate that, I'm going to get 29 times pi, which is equal to 91.1. So let's go through and let's just find one of these at a time. Because all three of these ratios are equal to each other, piece over whole, for degrees, area, and circumference, we can set those ratios equal to each other. So let's always use the ratio where we have both pieces of information. I need to use my first ratio, 28 over 360. And I want to set that equal to my second ratio so I can find my area of my sector. So my second ratio for area is the piece that's missing divided by the whole, 660.52. Now all I need to do is cross multiply. Cross multiply. 360 times x is going to be 360x. Don't forget your equal sign because some people cross multiply and they forget where to put that actual equal sign. So now I'm going to multiply 28 times 660. 184. 94.56. And then we can divide both sides by 360. So after I divide by 360, I get 51.37. Okay. Sometimes you won't be required to actually multiply by pi. So they might have left the area in terms of pi. They might have said 210.25 pi. And then you would have had your final left in terms of pi also. But I think when we're first learning this and we're not too familiar with circles and what does pi represent, it's easier to visualize that the entire area now is 51.37 inches squared. And I really shouldn't say entire area. I'm really saying that the area of this sector, just this green piece that I filled in, I now know is 51.37 inches square. So that's the area of the piece. What about the arc length? So again, the arc length is just the distance between the angle that's formed. So sometimes we'll even see this is labeled point A, point B. I want to know the distance between A and B. That's where my circumference piece over whole comes from. Arc length is just a piece of the whole circumference. So I want to find that now. And again, I can just use my degree piece over whole, just like I used for the area of the sector. My setup is very similar. So I'm going to take 28 over 360. I'm going to set that equal to the arc length, which we don't know what the arc length is. The total circumference we already calculated is 91.1. And then we do as before. We're going to cross multiply. All right, 30 times S is just going to be 360S equals, I have 28 times 91.1. We have 2,550.8. Last step, we need to divide by 360. So my arc length of S is going to be equal to 7.09 if I just round up to the nearest hundredth. And this time I'm measuring a piece of the circumference, which is just a measure of length. So this is just inches. So we'd say 7.09 inches is now my arc length, and I could add that back to my diagram. 7.09 inches. So there's a way to solve two pieces of missing information using the same formula, piece over whole equals piece over whole. This I find to be super easy to remember instead of the formulas that do give you the answer in a more straightforward way, but you do have to do a little bit more memorization. This relationship of piece over whole really helps students to understand what's happening on a fundamental level. I would really recommend trying to encourage them to identify what is my piece for this problem, what is my whole, and then we plug it into piece over whole. Let's look at a few examples here in an actual test setting where we could apply piece over whole. So we have this Ferris wheel. The diameter is 820. Okay, I could also easily find my radius if needed. Just as a side note, my radius is going to be 410 feet. And we have a central angle of 45 degrees is used to construct this Ferris wheel, and it separates each section from the other. So we want to know the length in feet of this section. This looks like arc length to me. Arc length XY. So that's at a piece that we don't know what it's going to be. So I've already started thinking piece over whole. Okay, I have a piece. I'm not sure what it's going to be. But if I'm measuring the length of that outside circumference, and I just want a piece of it, I know that my whole is going to have to be my circumference. Whatever my circumference value might be. That's just, again, using this relationship, degrees, area, circumference, they all have this relationship to each other. So I'm just choosing to use the fraction or the ratio that applies to my problem. So my problem is dealing with more so circumference, not the area. So I'm going to focus on that. So piece over whole equals, well, I need another piece over whole. Luckily, it looks like they give me this central angle here. My piece of my angle is going to be 445 degrees. My whole is always 360. So the only thing I need to find is circumference. Well, luckily, my circumference is equal to diameter times pi, or 2 pi r. But since we have diameter, we might as well plug it in. So we have 820 times pi. You could leave that in terms of pi, or you could multiply that out. I would say it's personal preference unless you're specifically told to do one or the other, or if you have a multiple choice, you would have to go with what the multiple choice options are giving you. Here, if this is fill in the blank, we can kind of go with our preference. So now I know the total circumference value. I could simply plug that into my equation now, piece over whole, right? And I cross multiply. Piece over whole equals piece over whole. Cross multiply 360x equals, if I multiply my circumference times 45 for my degrees, so all I did was I multiplied these two together, I'm going to get 115,924 point, we'll round up to 8. Divide both sides by 360 as we did in the previous examples. And I should get x equals 322. It says 0.01. I mean, we can add it if we want to be really particular. Feet. Okay. If I go back and read, because reading can be, a challenge sometimes, it says round to the nearest whole foot. So we'll just keep it at 322. Okay, excellent. Now, does this make sense for our answer? Well, a Ferris wheel is a really big object. I think 322 feet definitely makes sense here, so I'm happy with my answer. I'm going to go on to the next one. Okay, we have another circle related problem. Spoiler alert, this is going to be a piece over whole. So let's keep that in mind as we read, try to figure out what our piece is, what our whole is. So we have this key lime pie that's serving, really large slices. And we have a measurement of 100 degrees. Already my head is spinning. I can't wait to set up my equation, piece over whole. So my piece is 100, my whole is 360. And now I want to keep reading. It says, what is the area of the slice in the square inches? So I'm already thinking I need to find the piece of the area. I'm trying to stick with my color coding here. If I go back, I notice piece over whole degrees is going to equal piece over whole area. So my entire area, I'm going to need the formula for the total area. That's going to be pi r squared. In this case, my r value is 4.4, which I'm going to square that, times pi. So I get 60.82. That gets to be plugged into the whole area of the pie. Remember, a pie is not as big as a Ferris wheel, so we shouldn't be expecting, a huge, huge area for this problem, for the total. Right. So when I set up piece over whole equals piece over whole, it's really easy to just cross multiply now. I'm aware, yes, there are going to be some quicker ways to do this, but this is the best strategy I found to where you don't have to memorize a specific formula. All we have to remember is piece over whole, and the rest is really easy, I think. So we have 360x equals, if I multiply this by 100, I'm going to get 6,082. And then I just need to divide both sides. And I get 16.89. And I work on my reading skills, round to the nearest tenth. So I'm going to round this to 16.9 inches squared because, again, I was finding the piece of an area. So I need to make sure I'm using my correct units. So the area of the piece is 16.9 inches squared, final answer.